Today, we're going to talk about using Amazon Q and QuickSight for retail analysis. Specifically, we're going to show an example of analyzing customer behaviors related to keeping appointments.
I'm Ruben Lawrence, and I'm a senior analytics consultant with Ironside, and I have 18 years of experience in the analytics industry.
I'm Jackson Dowden, and I'm a partner solutions architect at AWS, and I specialize in data analytics and Amazon QuickSight.
If you offer retail services and let customers make appointments, you know that they don't always show up for those appointments. This represents lost revenue and lost time for your business. Understanding the data around these no-show customers can help you develop strategies to mitigate the impact on your business from unreliable customers. Our retail sporting goods store offers appointments for bike repairs, shoe and gear fitting, such as hiking packs, golf club fitting, even personalized services for planning outdoor adventures. If customers don't show up when their appointment is scheduled, that's a real opportunity cost because our employees didn't need to be waiting for a customer to appear. Let's look at how we can analyze the data around customer no-show behavior with service appointments. Moving to our Amazon QuickSight dashboard for retail, we can navigate to our tab for analyzing appointment keeping. On the dashboard, we have a few visuals here that are primarily tracking two key metrics: whether customers showed up to their scheduled appointment or not, and how many days ahead of the appointment it was scheduled. So the visuals on the left are tracking the average of how many days ahead appointments are scheduled by store, with a gauge chart tracking the overall average check-in percentage. There is also a scatter plot on the right that is showing the relationship between these metrics, plotting the days ahead against the no-show percentage.
Yeah, and looking at the scatter plot, there's a clear correlation between days ahead and no-show percentage, meaning the longer ahead of the appointment that it was scheduled, the more likely customers are to not show up. This is exactly what we expect, as of course, the farther away the appointment, the more likely the customers are to forget about it or for other things to come up, causing them to skip. Now, while we could do an investigation into individual stores, the overall trend across locations is clear. But before we start thinking of actions we could take to try and reduce the no-show percentage, let's continue with some additional exploration to try and gather more context.
While the dashboard visuals show the current data, we might be interested in what is happening over time to these metrics. We can use Q to investigate this. First, we set the topic context to appointment keeping, and we can then ask, what is the average days ahead since June 2023 to see what's been the trend in the past year?
Yeah, and we see that appointments are typically getting booked over 40 days ahead, with some month-to-month variation. Let's imagine that we're going to start an initiative to bring that down by training more staff to be able to handle the various customer services at appointments. That should allow us to improve the number of appointments we handle per day in the stores and bring down the days ahead that customers have to book. However, if we put this training program in place, we'll want to know what the impact is. To do this, we need to know a hypothetical. What would we expect the booking days ahead to be given the history?
Fortunately, Amazon Q and QuickSight can provide that as well. If we select the light bulb icon for insights on the time series plot, we get a number of machine learning powered insights. Scrolling to the bottom of the list, we see that the forecast provided by Q predicts the average days ahead will be 43.86 days this month. We also note that the growth rate calculated by Q is 1.23%. So the situation is slowly getting worse over time. We can even have Q forecast further for us by enabling the forecast toggle at the top of the menu. This projects the metric over a year forward in time, showing both the average and the forecast model range of uncertainty in orange.
Yeah, with that forecast available, we have a baseline that we can compare the improvements driven by our training program initiative. We hope that we'll be bringing down the number of days before a customer can get an appointment for service. If we find that it's less than the Q-powered forecast, then we'll have some quantifiable evidence that the program is working as desired. We also expect to see a corresponding reduction in the no-shows, reducing the lost time of staff that would otherwise be waiting for a customer that might never arrive. Prior to conducting our investigation and forecast with Q, all that we knew was that the longer customers booked ahead, the more likely they were to skip. We have plans to implement an employee training program to improve these metrics, but we wouldn't have been able to quantify the impact easily. Some might even resort to exporting data into a spreadsheet or analysis. But here, by using Amazon Q and QuickSight, we could pull up a forecast and estimate growth rate of our KPI in seconds without writing a single line of code or calculating any formula. We might try different strategies in different stores for migrating the cost of customers not keeping appointments. Some might start overbooking if there's a chance of no-shows, or they might charge a no-show fee to discourage customers from skipping appointments that they've booked. Regardless of the approach, it'll be key to monitor results in a quantifiable way, including what the forecast would have predicted without the initiatives. QuickSight and Q give immediate quantified insights to those machine learning powered predictions. And the point is that Amazon QuickSight and Q specifically allowed us to explore our data and showed us machine learning-driven insights, including forecasts, to understand the impact to metrics when we take specific actions, enhancing our ability to use our data to quantify impacts and enable data-driven decision-making.